Okay, thank you. So if you're wondering, we changed the title slightly due to a reviewer suggestion. So we asked, is one source enough? And then the reviewer said, one source is never enough. So what you will see in this talk. So what is our motivation? Systematic reviews in research aim at systematically collecting and analyzing all relevant research of a question or topic to show our current knowledge. They are the basis to make evidence-based decisions in research or in practice and politics as well. So you might have heard of systematic reviews as a method, and it seems to be the rising method in many disciplines. And you can see it right now on publications which report about 80 reviews a day in a discipline. And I did a quick dirty search in the Web of Science, and you see the numbers are rising each year. So I'll shortly introduce the review process. So we have 4 core steps. So the investigators decide on relevant publications on a topic or research question. They analyze the results, do some meta analysis, and then they can give recommendations. And the most crucial step is the first step. That is the search for relevant literature in proper sources, that is databases or information services. So this search determines the outcome of a review, because an investigator can only decide on the publications, on the relevance of publications they know of. So our motivation was specifically for the educational science, educational research, how many sources are needed and which sources are needed to do a high quality review. In current reviews, you often see that investigators only apply one source or just a few sources, and we want to have more evidence-based knowledge, specifically for the educational sciences. So there are textbooks and guidelines for good quality review searches and the review screening and so on. For example, the Campbell collaboration. They have a list of databases specifically for the social sciences and education. And they have search strategies, tips on search strategies as well. And there is PRESS, for example, peer review of electronic search strategies. And they define quality criteria for databases and for good searches. However, they don't recommend specific databases for educational research. The speciality of educational research is that it is highly interdisciplinary, so many relevant questions worth synthesizing in reviews are researched in several disciplines like pedagogics, psychology, or sociology, and relevant literature is spread across numerous databases and web sources. The Cochrane guideline for the medicine and life sciences reviews, they currently recommend 3 databases, that is Central, Medline, and Embase. In this discipline, the trend is to have to apply more sources, but there are many studies for this discipline who report that PubMed and Medline have a good coverage of relevant publications, and they are it's enough to just apply them as a source. But for educational research, we currently lack knowledge on optimal databases and database combinations in this field. So our goal is to find evidence on good databases for an extensive search for educational systematic reviews. And in this study we have 2 main questions. The one is which databases index relevant literature for reviews, and which combination of databases most efficiently covers all relevant literature. So what was our method? We reused data from sub-reviews, from 2 extensive review searches from educational research. The data is stored online in a research data center. And we used all relevant publications assessed by experts as a gold standard. So all in all, we had 325 publications. And the investigators of the original reviews, they applied 7 databases. In more detail, we have Review 1 on the role of pedagogical staff in implementing digital services, and Review 2, R2, on organizational development in educational institutions. For both reviews, there were 5 different searches for subsectors of educational research, that is school, early childhood, teacher, adult, and vocational education. But in this talk, I will only talk about R1 and R2, so Review 1, Review 2, and the differences. So these are the 7. I have another slide here. Oh no, it just looks differently. These are the 7 databases the investigators in the original review searches applied. However, they did not apply all 7 databases for R1 and R2. They changed. So both reviews were done. There was a time, like about 1 year, 1.5 years between both reviews. And for example, for the second review, they dismissed Google Scholar because they couldn't filter properly, so they did not apply Google Scholar for R2. They added the Web of Science, for example, or LearnTech-Lib. So we search for the relevant publications in all 7 databases, but the original reviews were different. So what did we look at? On the coverage, on the one hand, so the number of retrieved relevant documents in relation to the number of relevant documents at the gold standard. Then the similarity of 2 databases, that is on the common number of unique relevant documents in 2 databases, and the combination, that is the number of relevant documents retrieved in either database A or database B. So what are the main results? For your information, the data is available online in the Open Science Framework. So what about the coverage? So all in all, you see that we could find about 97 and 98% of all relevant documents for R1 and R2. We did not find 6 respectively 2 publications that are not indexed in any of the databases. Originally, they were found via hand search, and I come to this later because the number originally found via hand search is much higher. So what you can see is that, for example, the relevant for educational research, the relevant database ERIC has begin with Google Scholar, as you can see. Because Google Scholar, as we expected, outperforms all other databases when you specifically search for a single unique publication. If you look at the other databases, you see that ERIC, very important databases for education and research, is quite good, has a quite good coverage in both reviews and education research complete ARC, for example. So on this level, R2, the results for R2 and R1 are pretty similar. But if you look more closely to the subsectors, so the kind of sub-questions for both reviews, the results are they show some differences. So again, as said, Google outperforms all other databases. You can see it here. We almost find all sources in there. But then it seems that some databases have a focus of specific subsectors of educational research. For example, ERIC seems to focus on school and teacher education, similarly ERC. And interestingly, the more nationally focused database, FIS Bildung, has many publications on early childhood or on vocational education. Similarly, the German database DNB. So there are slightly differences between R1 and R2. So what about the combination of 2 databases? This is for Review 1. As you can see, a good combination where we find many relevant publications is if you have an international large databases like ERIC or ERC combined with some more nationally focused database like the FIS or like the DNB. And we then looked for the similarity of the databases, and here you can see that the ERIC and ERC, for example, have a high similarity coefficient. It's based on the Cosin coefficient, and you can see that the more national databases have less similarity with the bigger databases. And these results are similar for R2, as you can see. So this combination seems highly efficient, and similarly for the similarity coefficients. So what we then looked at the best combinations for the databases. We dismissed Google Scholar here as well because we know that the investigators dismissed Google Scholar because you could not, you are not able to filter the results and to find the good relevant publications via Google Scholar because of the search interface. And then our question was, which combination of the other databases leads to good coverage? And these two figures show the best database combinations. So you see for R1 we come up to 93%, and for R2 to 90%. In the first case, R1, the Web of Science and LearnTech-Lib do not have any further effect. Thank you. Yeah, so these are the best combinations, but we do not get to 100%. Our results cannot provide any concrete advice for applying, for example, the Web of Science for a discipline-specific review topic. The Web of Science is, however, is often used in review and often as a single source. And moreover, for R1 and R2, the more specialized databases, FIS Bildung and the DNB, they lead to slightly higher coverage to their individual documents. So next step, we had to look at these unique documents. So we as well have numbers for Google Scholar included and without Google Scholar. And here you see the unique publications that are covered by ERIC, FIS, and DNB. You see the number gets even higher if you do not include Google Scholar. So these are the relevant publications that are unique for this more nationally based databases, FIS and DNB, but for ERIC as well. So what are the practical implications we can give investigators who want to do a systematic review? So the discipline-specific databases like ERIC and ESC, they are of course highly relevant. The more nationally focused databases, they offer individual relevant resources for specific review questions, though they should be considered. However, for the subsectors, so school or vocational educations, in both reviews, the results are not distinguished to make concrete recommendations on specific database choices. So the investigators of systematic reviews should more likely choose databases that are not similar in their collections, or they should not dismiss the maybe smaller, more national-based one. They might have relevant resources. They could leave out, maybe if they have time capacities, very similar larger databases and just apply one source. Moreover, we know from the original review searches that they applied meta-search databases, for example, the German Fachportal Pädagogik. They are, of course, efficient to search in multiple sources. However, these databases do not always cover all resources. So investigators have to be careful. And in practice, investigators of systematic review conduct several searches at different times. So it's not one search, but it's several searches, and they including hand and explicit author search. So a hand search, for example, includes web search and a search on institutional websites. And with these strategies, they identify more relevant publications, which might be indexed in databases, but are not detected via them. And that was very interesting. We said at the beginning, only 8 publications were not indexed in any of the databases at all. But in the original search, the investigators found over 60 relevant publications via hand search. So that was due to the search terms they applied, due to the low keywording and the metadata of these relevant publications. But thus even the best databases might not replace the further search strategies in practice, because practice follows different rules. Moreover, the relevance decisions on publications might change over time. And as I said, the proper search terms are lacking. And in this example, we think that the investigators did not double check the search terms and then did do further searches in the databases. Again, they just searched via hand search. So come to the conclusion now in the future research. So we did a first attempt to get more evidence for the choice of databases for refuse in educational research. Some databases are very similar in coverage, while national and discipline-specific databases hold publications that cannot be found elsewhere. As expected, Google Scholar performed all databases regarding recall. However, due to poor precision, and we know this from other studies as well, practical application is difficult. We could no distinct conclusion on best database or combinations could be made for the sub-sectors or sub-questions of R1 and R2. So there's more research needed, and specifically in educational research on more refuse to get more evidence for the best databases and their combinations. However, investigators should carefully consider their choice of databases and be transparent on the criteria for inclusion and exclusion of sources, as well as on search terms and their validation. So thank you very much. I'm looking forward to your feedback.
Peter, once again.